Cool. So we got to a point where we were basically tilting the device, and it was showing an X, Y, Z of like the tilt. So did anyone have a look at it to work out which axes it might make sense to make a game where it tilt like that? Okay, it's the x-axis. Yeah. So what we're going to do is, if we have a look at our devices with where it's all built in, hang on. What should happen is the text along the top, if you have your device in front of you, should have 3 numbers, and those numbers are going quite crazy. But if you have a look at them more specifically, it shows how much of a tilt in a particular direction is. So like I was saying earlier, it's kind of like a joystick, where when it's default, it's at 0. And then if that's a 0, as it moves this way, basically it goes between 0 and 1. So that would be 0.5, 0.6, 0.7. And it goes the other way, so minus 0.1, minus, and so on to minus 1. So x would be around this axis, whereas y would be around this axis. And z is kind of very strange, yeah. Z is kind of around that axis. Yeah, Z's kind of like around this particular angle, but we're not going to use that. So x is the one where it determines how much of a tilt we have each way. So what we're going to do is we're basically going to work out how much of a tilt x has and apply force in that direction that we tilt in. So if x is greater than 0.4, push it to the right. If x is less than minus 0.4, push it to the left. Now, can anyone tell me, or have a guess, why we would use something like 0.4 either side to detect when it's tilted so far away? Does that make sense? It's because if you're holding it like that, technically the accelerometer is still in play, unless we're putting it down on the table, in which case you're actually not playing the game. If you're holding it like that, there's still some form of acceleration process. So if we said anything greater than 0, so towards going right, you'd literally hold your device like this, and it will be like 0.0001, and it would just shoot off to the right, and you haven't even moved it yet. Or if you held it slightly to the left without realizing it, I mean minus 0.002, and it would just shoot straight off to the left. So we have to use some form of dampening to say only when we've tilted it to a certain point, then apply the force to the right, and so on and so forth. But don't worry, because that's super easy and super simple to implement. So what we're going to do is we're going to go to our script. We're going to scroll down, and just underneath where we do the tilt display is where we're going to apply our force and do all the force bits pieces. So we've already accessed the tilt vector, which is x, y, z. And what you'll notice here is when we output the text, we said x is tilt vector.x. We're accessing the x component of that x, y, z coordinates. So what we're going to do is we're going to say if tilt vector.x is greater than 0.4, and I'm just going to put a little comment in there, tilted to the right. And then we're going to do an else if tilt vector.x is less than minus 0.4f. So at least we now have some form of like dampening to the whole tilt process. So awesome. So what we're going to do now is we're going to write a function which we're then going to pass in which direction we want to apply a force in. So we're just going to make a function underneath, outside the update, called apply force. And that is going to have a vector 3 of force direction. And we're going to tell it go to the left or go to the right. And as our ship has a rigid body on it, we can then say something like rigid body dot add force direction by force power. Cool. And obviously we're going to write in here, and we're going to pass in the parameter. So if we're tilting it and it's greater than 0.4f in the x, and it's tilted to the right, what do you think we're going to put in here? What vector 3 dot something are we going to put in? Yeah, it wasn't the most difficult of questions. Yeah, vector 3 dot right. So we're just going to pass in apply force towards that particular direction. And the same thing happens the other way. So we're going to write apply force vector 3 dot left. Also, minus vector 3 dot right works the same as well. So minus vector 3 dot right is vector 3 dot left. or you can just write left. Cool, so I just added in this bit here and function at the bottom. And then we're going to set up things such as the force power in a second. Cool, so those of you that have written that code down, make sure you add the force power bit. So has everyone got that written down, or a couple of people typing? So all I'm going to do is I'm going to scroll to the top. I'm going to add a public float of force power. So in the editor we can like state how much force it is. So is it too much or too less? I think the ideal amount is 10, force of 10. 10 or then so it might be a thing to play around with. So I just added that function, that variable, the public float force power, and then down here we're basically going to apply that force when we want to go to a specific direction. Awesome. So try building that and then tilting your device and see if when you tilt it to a certain point, and try looking at the X number in the corner so that when it reaches 0.4 then the rigid body kicks in, and when it reaches minus 0.4 and then the rigid body kicks in the other way. Yeah, so that's kind of like the basics of doing accelerometer stuff and like tilting stuff. It's basically getting all X, Y, Z, then narrowing down exactly what you want about that X, Y, Z. So like which of these things you want to use. Or use all of them if you really want to.
What value of force power?
Oh, okay, so I'll set force power at the top here, and in the editor I'm going to set it to be about 10. Having force power at 0 won't give it any force. You're multiplying something by 0, so it's 0. Yeah, so I'm going to set it as 10.
Can you quickly show the apply force for there?
So in terms of timing, I think I'm stopping at 2 o'clock. Is that right, Yuka?
Yes. How much? 45 minutes?
I feel like it's only invested about an hour-ish. So,
Okay, so maybe
Okay, cool. So what we'll probably do is we'll get the tilting working, and then we'll do some touch, like swiping and things like that, which is quite straightforward, like getting multiple fingers as opposed to like just one finger on the screen. Then do the sending a message from Unity to the Visual Studio side of things. It sounds like a lot. And then 2D stuff on top of that. So it will be a lot of bits and pieces, so we'll soldier on. Cool. So has anyone managed to build to it and see the tilting in process, or does it work? Or
Which value did you set to the power force?
10.
10, yeah, because 100 makes it very hard to play.
I'm not surprised.
Okay.
Did you just put in 100 just to see what it would do?
No,
Or-
I didn't really say 10, and 100 is my go-to number.
All right. Okay.
So what is supposed to be?
And also try firing as well as tilting, and you can see that now the ship moves left and right. There is no bounds, so you can hold it to the right and it will just carry on traveling forever. But you can fire, and you can notice that the spawn point is moving, as it's a child of the ship, it's moving along with it, firing in that particular direction. Cool, so has everyone got the code down? Right, I'm going to try a build. Oh, cool. So we now have a laser shooting flying spaceship. So you can notice that there's a slight, the rigid body, we might need to increase how much drag it has so it actually does come to a stop eventually. But you can actually see the tilt detecting when you tilt it to left and things like that. And in space, nothing is rigid and stops, it all floats. So you could take this and say when you tilt it to left, it actually translates it left, so it's more of a precise movement in the stop. But in this case, yeah, it's just more of a demonstration then. Right, I can see my lasers, but my ship has travelled so far, I can't see it anymore.
Can you run your app when you're not connected?
Cool, how's it all going? Okay, cool. So we've got a slight little tilt going in. So what we're going to do now is code comment out the tilting bit and then do swiping. We're going to code comment out a lot of this actually, because we're going to then write it basically, because this is more for like a single tap input and using tilting as a control, we're going to code comment this whole section so it's not, we're not deleting it and we can save it for later. And we're then going to set up a similar form of getting touch inputs and things like that, but for multiple fingers at the same time. So what our goal is to have our left button firing and our right finger wherever in the screen swiping left and right to then move the ship left and right. So you can actually have multiple inputs happening at the same time. So what we need to do now is just underneath where it says if Unity _ Windows Phone 8, put a slash and a star, and basically just code comment out all the way down to the end if. So now everything inside that platform defined is now code commented out for later use. Just in case you want to go back to it and you don't like what we're about to do. Well, I'm sure you will. Okay, so the method of getting all the fingers on the screen is by running a for loop every frame to cycle through how many fingers are on screen. So we already have a invisible array expanding and de-expanding and filling up all the fingers and not. Because what it's doing is every frame it's saying there are 0 fingers, there's now 2, and it's basically going to loop through and have this constantly expanding array. So all we need to do is access that, for loop through that array, and then get all the fingers and apply something to each of the fingers if they're doing a particular thing every frame. And that sounds a lot more complicated than it actually is. It's actually a very similar setup that we had before. So what we need to do is we're going to add a couple of variables at the top here. Multi-fingers. So the first variable that we're going to have is instead of getting the first touch and storing that, we're going to make a new touch variable and call it current touch. So this is going to be the one that every frame it's going to go through and it says there are 3 fingers. For this one, it's now current touch, do something. For this one, it's now current touch, do something. For this one, it's now current touch, do something. Then it's going to loop back around and do that same process again, depending how many fingers there are on the screen. Next thing that we need to do is create a vector 2. Now this vector 2 is going to be called swipe direction. So we're storing a vector 2. Oh God, where'd it go? So we're storing a vector 2 instead of a vector 3, because vector 2 only gets the x and y coordinates. And as we're doing a swipe on the screen, we're basically saying, my finger is here, swipe this way and swipe this way. We don't use it in a real world sense with x, y, z. Instead, we're just doing the screen's position. So the tricky problem that I had when I started to do swiping things is if I was getting the touch position, and when I get the touch position, basically if the bottom left-hand corner is the origin and it's 0, 0, and then I put another finger here, what I'd have to do is I'd have to get at the start what that finger was and then work out a difference between that particular point, and then all sorts of things were coming into play with that. There's a much simpler way of doing that, and that simpler way is to use a delta position. So still like I tap this screen here, what I can do with that position is say touch.delta position, and that is the origin point. That is 0, 0, 0. That is 0, 0. Then when I move my finger left, it's going to say, oh, it's minus in the x, it's greater than the x, etc. So it's kind of like this whole tilt where it says this, it's minus, it's plus. Instead, without having a finger, it says it's minus, it's plus. It's kind of like doing a joystick from this middle point, but using pixels of the screen. And that's basically what we're going to do. But we're going to do this touch phase thing. So when it begins, it's going to get the delta position as the origin. Then if it moves, it's going to say it's greater than that position, it's less than that position. And we're going to do it all in a case. So it's going to go through for each finger and loop through what the finger's doing. And yeah, this is going to make a bit more sense. So we have our private touch, current touch, and we have our vector2 of the swipe direction. So that's just storing x and y of where the finger currently is. So if we scroll down to the bottom of that commented out statement, we're then going to write, we're actually going to uncomment the first line which is saying finger count. So remember I said earlier on, I always include a finger count in an update basically to find out how many fingers are currently on screen. So I can lock it. So in this example, if finger count equals 1, allow them to do stuff, and if it equals anything else, don't allow them to do anything. In this case, we're going to get how many fingers are on the screen. At the bottom then, what we're going to do is we're going to say if finger count is greater than 0, run some things. So when there's no fingers on the screen, so I just put my phone down, or I'll go off and do something, I don't want it to be constantly looping through my fingers and running all this code. I want it to basically say there's no fingers on the screen, don't bother doing any of this stuff. So now we're just going to do a simple if statement. So I is less than the finger count. We're now going to basically run a for loop every frame for how many fingers on the screen. So if I have 10 fingers on the screen, it's going to go through and loop this 10 times. If there's no fingers, it's not even getting to this point in the if statement. So yeah, we're basically looping through until I reaches how many fingers are on the screen. And then every loop it's going to do through, we're going to say current touch equals input.getTouch. And instead of beforehand where we used 0 to get the first one, we're actually going to do I now. So whereas before we were getting the first touch, now we're looping through and getting every touch, assigning its current touch, and then accessing that little gold mine. And this is where we can then do our switch statement. So are you all know what switch statement is, right? Yeah, okay, that's cool. I don't explain that. So what we're going to do is for the switch statement, we're going to use what the phase is for the thing that we're switching. And inside here for each case, we're going to say case touch phase dot began. Okay. So hopefully this makes a bit more sense. So basically, there's more than 0 fingers. It's going to loop through how many fingers on the screen, on the current frame, store what current finger it is doing in the loop. Then it's going to go through the switch phase to find out what that finger is doing. So rather than having just a ton of if statements, we're going to use the switch to say the finger has just begun its touch phase, do something. The beginning finger has just done the move. Otherwise, what we're going to do is it's going to say, finger has just begun, do something, it's just moved, no it hasn't, it's just stationary, no it hasn't, it's just ended, no it hasn't. We're instead just going to use this to basically detect what it's doing. So if the finger has began, we can then do the whole hit test to see if that finger is within that shooting area. So you can copy and paste from that bit lower down, or you can just write out the hit test. So if the frame comes around, we've just begun it, then it's going to say, okay, and if it's hit testing with our laser button, then we're going to fire the laser. So moved basically says, if the finger is now currently in a state where it's moved from its previous position, then do something. So what some people do for swiping is in the began section, they log where the location is, all these things. Then in the next frame, it finds out it does a comparison, does which direction of the screen it's moved, how quickly it moved to that point, how far that point is from the original point. They really narrow down how far. So if you're doing something like this, where you have this, oh, okay. So if you do something like this, obviously there's going to be reach a point where I'm going to have to swipe to the right at a particular speed to bring up this menu. If I do it too slowly, okay, I have to do it to a certain point. It's not going to do it straight away. So it's basically getting the distance of how far my swipe is going. Kind of don't have time to go into that sort of thing, so we're just going to do something really simple. Now, I don't want to be able to just use my left finger for the whole game. I know that sounds really mean. I want to use my left finger to fire, my right finger to move. So what we need to do is we need to do a hit test to see if it's not touching the laser button. Because we don't want to just have our finger on the laser button firing while swiping and saying, oh yeah, I don't even have to think about it, I've got auto shoot on. What we want to do is we want to say, if the next finger, so the second finger to touch the screen, is not touching the button, then do the swiping. So that would just be a case of writing laser button dot hit test. So if it's not doing that, then do a swipe.
Both if cases you need a second right parenthesis. That's why.
Oh yeah, I do as well. Sorry. So inside this one is where we do all our swiping business. So swiping business. So what we're going to do is, if it's moved, we're basically going to get the swipe direction equals current touch dot delta position. So if it has moved, it's basically going to say store where it currently is, and then what it's going to do is it's then going to say if it has moved and the swipe direction is, for example, greater than X, that means it's moved from the right, so it's moved in that particular way, then apply a force to the right, and so on and so forth. So we can then just write something very easy. So it's greater than X is to the right, so right. Not Apple force, apply force. Obviously with a capital. Sweet. So once that's all working, that should work fine. We're just using that force that we created earlier on when we were doing like the tilt. So plug in your devices, build over that original project, and see if it works. And you can go way more in depth with this. So for example, in the began, you can detect where it was in the previous frame, for example, and then where it's moved to now, how far it's moved in that time. Yeah, there's all sorts of swipe specifics you can go into. This is just like a very simple example that you can basically expand on.
Maybe it's less than 0. You have to apply force to the left.
Yes, you are right. Okay, yeah. So swap the left and right around. Sorry. Yeah, you are right. Yeah, so less than 0, it's to the left. It's greater than 0 to the right, yeah. Yeah, cool. Thank you. Otherwise everyone's going to be flying their spaceships backwards. Cool, so has everyone got that written down? Or? Cool. I'm now going to try building it. Cool. Who's managed to build it? Right, mine's building. How are people's? Hello. How's it going?
So what you'd have to do is you have to say if it's greater than 0 fingers, but
Cool.
less
So
than
what we're going
3,
to do now
so you can
is
really use 2 fingers.
sort of rush everyone forward.
that's
I want
like
to get as much
just
stuff as possible. We're now going to do create a class,
It depends
static
on the
class
game
in
you're
Unity,
making.
and basically send a message through to the device to vibrate it on the other end in C# once we build our Visual Studio projects. Right. So the way that we're going to do that is 1 or 2 things in the Unity side of things, and then 1 or 2 things in the other end. So kind of like we're sending a message from one end and catching it on the other. And I'm sure you can do it the other way back. I don't have an example for that, but I can get that example. So let's have a look. So what we're going to do is we're going to make a static class, and this is basically going to be like our event handler that's going to catch the call on the other side. So under our scripts folder, so where our spaceship script is, we're going to make a C# script, and we're going to call this static interrupt, and open up that static interrupt as well. So this is basically just going to be a static class that sits in our project, and it's going to wait for this function to be called. And when this function is called on the other end, it's then going to basically do some things dependent on the device. So as we want this to sit in our project folder, we don't want it to basically DOM mono and have to be within our thing. We're going to take out this mono behavior bit, so it is just a purely, it's plain simple class, and get rid of all that as well. So inside here, what we need to do is we need to make an event handler to basically handle the fact that we're calling it and how that the Visual Studio side of things basically understands it. And let's call this vibrates me. So what you'll notice here is that it doesn't understand event handler. It's basically like very confused because we're using a system thing. So we have to write at the top here system. So like I pointed out yesterday, you can basically extend Unity and include various things. So if you want to use like a list or a dictionary and things like that, you'd write using systems collections .generics and things like that. If you wanted to use their Facebook SDK, you'd write like using Facebook.SDK. In this case, we're using the system, so the particular system we're building to. This is kind of like how you would get the current time on your device, or get your photo library, or get your contacts list, and if you want to use a contacts list, and bring those things in. So if you wanted to get the time on your device, you'd use using system, and then you'd write system.time. So on and so forth. So in this case, we're using the system, and we have an event handler. So we're then going to write a function, method that's going to be called from wherever in our game, saying when this is called, fire vibrate me. And then if vibrate me, if that event is running, then run that. So yeah, basically that has some form of red. Why is it doing that? So yeah, we're literally, this is just the bridge. This is basically the thing that's going to be inherited on the other side, and basically, yeah, what we're going to be able to call.
When you put in now, can you put in this in the first one and access that object?
Yeah.
Since it's the sender, probably. Like, okay.
Yeah. It's actually on the other end that we handle a lot of the stuff about the vibration. This is literally just sending messages out. So we use static interrupt, and we could call the event handler, for example, get geolocation or something, and then on the other end just run a function called get geolocation, and then when we get to the other end, then we do all the geolocation stuff that's specific to the device. So the vibrate me stuff is just kind of like just the function that I'm calling. So what I would do is if I had wanted to access a lot of things that are on the Windows device, I'd probably have lots of static classes in here, or static methods in here, all with controlling the vibration on the device, the location of the device, accessing your photo, all those sorts of things just from this one class, so that I don't have like 50 different scripts. I have like just one script handling all the the bridge bit. Cool. So what we're going to do now is we want the vibrate to happen at a certain point. So this could happen when like an asteroid collides with a ship, or we pause the game. That's a bit strange. But in this case, we're going to do it when we fire. So if we go down to fire laser, what we're going to do is we're basically going to say static interrupt dot fire vibrate me. So then it's going to go to that static class, run that, and then once we built it to the device, it's then going to say, okay, it's now running. What do we want to do with this on the other end? So these names of fire, vibrate me and stuff are all kind of like just a bit general for the specific thing. So you could have get location, or post to Facebook, or update tile, or something like that. So you could push out a score, I guess, to the tile. I haven't tried it, but in theory, we're just sending information. On the other, you just have to catch it and display it in a way that looks presentable. Cool. So that's the Unity side of things. So all we need to do now is just build it over our Space Blaster build. Unless you have a vibrate rumble pack on your edge. That's what happens when you're burning to disk, though. Oh, okay, I've got a... Oh, it's currently running at this. Rookie mistake. Cool. Okay, so Visual Studio side of things. So what we now need to do is we now need to go into the main page that's been created and add a couple of bits and pieces, because that's basically going to be the root of where that general message is happening. So when we click, if we built this now without this, it will probably, when we click fire, there's going to be some form of null reference exception or whatever, because it's basically calling a function on the other end that doesn't exist, if that makes sense. Pardon? Yeah, nothing happened. Okay. Okay, whereas, yeah, so it's kind of like if I'm throwing a ball to you and then you decide not to catch it. Yeah. So now what we need to do is we have to do the catching on the other end. So so we have to open up the XAML file. Opening the file. If it wants to open up the file. Okay. Perhaps not that. Okay, we need to open up the example.cs file. Sorry. Okay, yeah, this is more like it. So what we've got here is it's basically showing that it's using the Unity app, using Unity Bridge, Space Blaster. It's basically saying on the main page, set the bridge, initialize it, draw the surface background, load the callback, get the orientation, if it's been navigated to. It's kind of like all the things like your setup, so when you close the app, what happens, things like this. So this is where you'd go if you wanted to access extra things or add other bits and pieces. Or get a blue ring of death. Okay, cool. No blue ring of death. I think there's a callback for exit as well. So if you exit your app, you could then say pause the game or mute the music or something like that. Yeah, cool. So what we're going to do at the top is we have to add a couple of things. So as we're using the device, because this is just a general build for the Windows phone, we basically have to include the fact that we're using Microsoft devices, and all your phones have like that have a rumble feature in it, like a vibration feature in them, right? So when you click the back button or the home button, it's going to does that little jitter. Does that make sense? Or is a jitter the best way to describe it, or has it got official term? No official term. Okay, it's now jitter from now on. So what we need to do is we need to add to the top that we're using the device. Okay, devices. So we've added that device bit in there. Then inside the main page of the class, we then need to add a variable. So this is basically going to be the controller that's going to control that call. So I'm going to call this vibrate controller, and I'm sure there's other ones for like geolocation controller or compass controller and things like that. In this case, this one's called vibrate controller, and we're going to call this the vibrator, and it's going to be vibrate controller.default. So what other types of vibration or does the device have? Because I'm guessing by .default it's the default vibration. Is there other ones like intermittent, or does anyone know anything about the vibration? Does anyone? Okay. I guess default's there just in case they want to do future stuff or placeholder vibration stuff. Okay, cool. So we have that vibration in there. Then what we need to do is underneath this bit here where it basically loads up everything and it gets the height and things like that, we then need to basically state, after it's drawn the surface, we then need to basically catch that thing on the other side. So static interrupt, vibrate me, and this all looks very familiar. We then need to add this. So this top class is kind of like, you know in Unity you have like void start, which is initialized at the start of the frame, then all the other bits and pieces. We kind of do the same thing. At the start of the app being made, it basically gets the content, it then loads up Unity, it then gets the native resolution, things like that. We then need to say, okay, in this initialization, we also need to get that function being sent and add that into this bit. So basically catch that ball on the other side, which sounds very strange. So what we need to do is we then need to say add in static interrupt vibrate me. And this is going to be a function that we're going to add in a second, or a method even, which is why it's got a red line underneath it. So now that we've got that function in there, we can then go wild to our heart's content. So normally what I would do is I'd write add all custom functions here. So this could be, for example, get geolocation data, open Facebook, update live tile. So yeah, these could all be functions that you call within Unity when you push like a certain button or you want to get where you currently are and things like that. So what you're going to do is then we're just going to write static interrupt underscore vibrate me because it's getting that bit. Then we add a couple of parameters. And then we can do all the vibrations. So we basically call it on the other end. So we have to set up a couple of bits and pieces, but thankfully when we rebuild the whole thing, we can then just extend this and add extra functions and messages from Unity. So in here, we're then going to go to that vibrate controller. So those who used Unity before, have you used the animation controllers in the state machines? I know you guys have, because I've seen you. Okay. Well, we'll do that in a sec after this bit here. But now what we can do is we can then say, okay, now this function's called, we can then do the vibration stuff. So currently all the stuff calling it vibrate me, vibration and things like that are all just completely general things. Now we actually do what we intend for it to do. So we're going to go to the controller, which we set up, and we're going to say, actually do a vibration. So we had to, using Microsoft.devices, which is going to control the vibration. Then after drawing surface background, so it's basically drawn the Unity content, it's then added that particular call, that function, that event into this system. It's like called it on the other end.
What about if we compile this DNA, this algorithm?
I'm not sure. Maybe not. Maybe it is. I'll test it.
Yeah, I'm sure we'll test it.
Yeah. Yeah, then we can write. So what we're going to do is we're going to say vibrator dot start So this is all like specific things towards the device. New time span. I think you don't have to put time span. You can just put something like 5 seconds or 5.0f to rumble for 5 seconds. I don't know. But here we notice that we've got days, hours, minutes, seconds, and milliseconds. And in milliseconds, I'm going to put, it's going to run for 20 milliseconds, which is about the length of the back button. But
The time span from milliseconds.
or you could do that, yeah. You guys all know this back end of this stuff, so you could probably do all sorts of awesome. You could probably make it intermittent and rumble, rumble, rumble like an alarm or something awesome. So okay, one thing I wouldn't recommend to do is make it rumble for 5 seconds because it really hurts your fingers every time you fire a missile. Because the rumble basically stacks on top of each other, so it's going to constantly be rumbling. First time I did this, I did try and set it to like rumble for like 3 days, which was kind of dangerous if it actually did it, but eventually just ignored it. So I think I read somewhere that there's like a limit of how long you can set the rumble vibration bit for, because 5 days my phone would just be sitting there for almost a week, just going until it runs out of battery. So I think 5 seconds is the cap, but I'm going to use it for 20. Cool. So now that we saved that, what we can do is put it on the other end. We've basically done all the vibrate control stuff. Now I'm going to build my project. So now when I look on the Windows Phone Store, there's going to be lots of spaceship shooters and fruit splat games. We've got about 15 minutes left. Is that right? Okay, so we do 2D stuff. So the fun thing with the 2D stuff is I could probably spend like days and days talking about all the tools about it. So in 15 minutes, it's almost like the most bite-sized thing that can possibly happen. So I'm going to go through the 2D tools and what there currently is. And you can either follow along with me, or I can do it as more like a talk presentation thing. Depends what people...
Talk is for we're recording this, so you have more time to go
Okay.
everything through.
And what I could do is I could get, I guess I could get like a list of everyone's email addresses, and I can send them like a whole load of links to videos and scripts and documentation about the 2D tools. And there's like, and there's like a free platformer project. Like, has anyone seen like the Alien platformer project? Yeah, so that is free on the asset store, so you can download that and look at all the code on how that's made and use it and things like that. So the Learn team have been very kind in making that and blow up aliens in London. Yeah, it's a very bizarre game, but that's cool. So with 2D tools, basically Unity's always sort of been a 3D engine, so it's aimed at 3D development and 3D games, 3D visualizations. But what some people did is they basically tricked the engine into being 2D and to render sprites and things like that. They built on top of the engine. So, for example, Bad Piggies, Kentucky Route Zero, there's a couple of things which are like 2D or mixed with 2D and 3D and things like that. So what Unity decided to do is, instead of a lot of people, 2D developers saying, oh, I'm not going to use Unity because I've kind of then got to learn the engine, then learn all this third-party stuff which may not be up to date and may just sort of not be developed further and things like that in future versions. What you decided to do is like, let's have some out-the-box 2D stuff in there so people have the option to go into 2D development. And the important thing with 2D development is you're not pigeonholed to either do 2D or 3D. You can either do a 3D game or a 2D game, or mix the two together. So you could have like a 3D map with 2D sprites walking around on the map. You could do something like Doom or Wolfenstein, where you have like your 2D sprite gun, and then like 3D maze around you, and then 2D sprites running towards you. Like Minecraft uses sprites for like the little pickups that they have. You can basically mix and match these things how you want. So yeah. So in 4.3, oh, and all the tools are free as well. So in 4.3, there's this little toggle at the top here that says 2D. So what happens when you click that is it basically locks off the scene view to the X and Y axis. And you notice that the gizmo has like a little weird iOS 7 takes too long to fade basically. And basically what that allows you to do is it allows you to view your game from this particular angle. Now you don't necessarily have to make your 2D game from this angle. This is just simply accessing a 2D gizmo. So if okay, let's use a brand new scene. So what I can do is if I go through my folder and go to sprites, I've basically got a couple of textures, and let's turn them all into sprites. And what I can do is if I select my texture here, which is like my, well, the Unity logo obviously, when I import the texture type, we set the previous thing as GUI, we have normal maps and things. If we set it to sprite, what that allows you to do is it allows you to, instead of use a mesh render, which is more for a 3D object, it allows you to use it for a sprite renderer. So it's basically made to take in the settings of the sprite and basically create a mesh around that sprite. So if I import that in, I can set it to be a single sprite or a multiple. So single would be something very simple like this. Multiple would be like an atlas of sprites, but I'll talk about those in a sec. So if I import that in, click apply, what you'll notice is that it's instantly gone from a texture and it's worked out where the alpha is on the image, and it's basically cut it out, that sprite out. So then if I drag my sprite into the scene now, what you'll notice is that we have a new type of gizmo. So if I toggle things into 3D mode, what you'll notice is that I can then take the sprite and basically edit it using the 3D gizmo. So I can rotate it around, I can even scale it, things like that. Yeah, and deform it wildly. But what I can also do is basically turning on the 2D mode, it didn't make sense for the 2D engineers to use a 3D gizmo in this 2D editor space. So by locking off, it does a similar gizmo to like, doesn't he use After Effects or like Flash? And so basically it's more like a gizmo where it has handles around the outside and made for 2D sprite editing and authoring. So we have our sprite like so. It has a pivot point in the middle which you can move when you import the sprite. You can basically rotate it around, you can scale it. Now it default sets to scale proportionately, but if you hold shift you can basically scale like a particular edge and basically flatten things out and things like that. So basically you can move your image, sprite how you want. Now in terms of 2D and 3D mixed together, so if I make a cube, and let's make the cube massive, the 2D gizmo only really works for sprites because this is still a 3D object, this cube. So as it's locked on this angle, if I go into 2D mode, well 3D mode, I can basically position the cube however I want. Now if I align the game view next to it, what you'll notice is that the 2D and 3D work together. So if I take the camera, it's basically rendering it from this particular angle, whereas if I select the cube, what I can do is I can move that cube in front and behind the sprite. That was feedback based on the beta of these tools. So when the beta went live for these tools, there was a closed beta with inviting companies and then more of an open beta. And what originally happened was the 2D sprites were always rendered in front of all the 3D geometry and all the 3D meshes and things like that. And a lot of feedback was like, we don't want this. We want to be able to mix 2D and 3D things together. We want to have like 2D health bars above players' heads and things like that. So what the engineers decided to do is make these things merge in together, so you could have a 2D sprite like some form of sprite animation mapped on top of a 3D TV screen or something like that, and movies and that. So what you'll notice is that I'm currently using a perspective camera. So as I move this cube in and out, basically it will scale on size. So true sort of 2D games, they don't use a perspective camera because everything is flat. So if I change that perspective mode into orthographic, what you'll notice is that as I move the cube back and forth in between it, all it's doing is because the orthographic view is more like a straight narrow tunnel, it's just popping it out in front of it. So you could make a game which has perhaps 3D mountains and hills and clouds in the background, then a little 2D sprite running and jumping on enemies, picking up things, then perhaps 3D geometry in front of that of like trees and grass and plants. So like you're passing through 3D things and mix them together. So if you know Paper Mario, it does that quite well, and not Little Big Planet. There's a couple of other games that do this, but yeah, so you can mix these things together. So what I'm going to do is I'm going to change the camera back to perspective and set it like that. So another thing that people tend to do with this, or that we found, is that if I dock the game view down the bottom here, is that they said, okay, so we toggle on the view to basically edit the 2D stuff like this. But then what we have to do is if I then position the 2D object and then I'd have to then go into 3D mode, position it, and keep toggling back and forth. Well, a neat little trick is that if you right-click the Scene tab, you can add a second scene view, and you could have one scene view at 2D mode, so basically editing all of the 2D stuff, whereas you could then have the cube basically in 3D mode. and basically edit all the 3D geometry in that 3D mode. So basically you can mix and match these things so you could have multiple scenes. So having multiple scenes is quite useful for editing different parts of your game, or having multiple camera points or things like that, or multiple areas. So yeah, this is another neat little trick. So I'm going to close that one and talk about 2D-ness. Yeah, let's get rid of the 3D. So we have our sprite, and the sprite has a couple of its own properties. So like the mesh renderer basically has what material it's using, what it's going to look like, the sprite renderer has a couple of things itself. So it's got a link which goes down to the sprite that we're using. All the sprites are also independently vertex colored, so I could change the color of the sprite to be red, and someone else shout out a color. Any color? Green, cool. I was hoping no one would shout out red, because it kind of defeats the purpose of this next bit. So what I'm going to do is copy and paste that sprite. So what you'd normally have to do in Unity is you'd have to have, for example, a different material for each different color of a thing. Where instead what we've got here is all the sprite renderer does is say, was it green that someone shouted out?
Yep.
Okay, cool. So what it does is every sprite has its own individual vertex color. So you don't have to make, if you have 50 sprites, you don't have to make 50 materials of different colors. You could just use sprites for everything and use its independent color. So there's a sprite material as well. So the default sprite material ignores lights. It's locked off from this angle. The normals are from this position, things like that. But what you can do is you can change the shader type away from sprite into like a 3D sprite, so it's affected by light. So you could have sprites like a horror game like Doom and have enemy sprites come into your light, and it would be affected by point lights and directional lights and things like that. But the default one is kind of like takes in the art color. It's not affected by light at all. Everyone okay with all that so far? Awesome. Cool. We've got 4 minutes, right. So we have another thing called the sorting layer. So another important element of 2D games is obviously things being rendered in front of other things. So you'd have some form of background, then perhaps your game in front of that. If it's like a puzzle game, then perhaps maybe some menus and things in the bottom and things like that. Now what you could do is you could do all of this in the 3D view, so basically position things in front and behind each other. That's kind of like a lazy way of doing it. What if you wanted everything all in one particular z-axis, so they're all on the same level? So what you can do is, with the sprite renderer, you can basically pick a sorting layer. So sorting layer is kind of like grouping a bunch of objects and say, you are rendered before this group of objects. So a prime example of this was if I'd have sky, mountains. I'm currently looking out the window doing this. So we've got sky, mountain, there's not many mountains, lake, then just for all of you Finns, a sauna. So what we could do is basically it's rendered from back to front. So we could then take this green object. So this green object is now going to be blue to represent sky, and say you are no longer on the default layer, you are now on the sky layer. Then we take the red object and say you are no longer on the sky, on the default layer, you are now a mountain. Yeah, I know it doesn't look like a mountain, but bear with me. So yeah, and then what it's going to do is it's basically going to order it in that stack. So it's going to go from default to sky to mountains to lake to sauna, and it's going to render it in that particular way. So then if I go out of 3D mode, what you'll notice is that no matter if I move this sprite behind the other one, it's always going to be rendered in front of this one, so you can have all the sprites within this view. So you could either use the 3D-ness to position sprites, or you could choose the sorting layers instead. Now, one particular thing that you can do is order in the layer. So whilst you have all these layers, and I'm really hoping people don't do this, is don't make a separate layer for every single item in your entire game, because if you think of something like Candy Crush, there's tons and tons and tons of sprites in that game, and they're going to end up with like thousands of layers. So what would make sense is to have, for example, the sky layer and all the items, and basically put them all within that layer, and then order within that layer. So they all start at 0. So for example, you'd have this bottle at 0 on the same layer as this cup, and then you could say, this is now a layer of 1, so it's higher on the stack, or on a -1, it will be behind it. So you're kind of layering within the layers, if that makes sense. So you can have, minimal amount of sorting layers, but then layer those things inside it. And the numbers go up to, so I could set this to be layer -100, and it will always render behind things on layer 0 of that particular layer.
Do layers only account to sprites?
Currently, yes. Now, you can access all these properties in script, so you can go and recolor things, you can move things from layers. So if you have, I'll use Mario for example, you get a power-up so you can stand on clouds. So what that would do is technically move the clouds from a back layer to your current layer. So you can say, go to the sorting layer, .name, change that to a different layer. I think they were discussing perhaps exposing the sorting layer with 3D objects, but it kind of like the 3D world makes more sense to move a 3D object in, whereas 2D world makes more sense to have multiple layers. So I'm not too sure if they're too keen on that, or...
I'm just wondering about the mix and matching the content.
Yeah. So currently mix and matching the content, just put all the 3D stuff and position it in the 3D world before and after things. Yeah. Cool. So it's past now, and I haven't even got onto the fun stuff. Okay, I'll show you one very quick little thing, and that's physics. So we have our object, like so, and going into component, you notice that it's now in two sections. So physics and physics 2D. So physics is just for the 3D physics, and that's using NVIDIA's physics system. It was kind of going to be a bit overkill off on a mobile platform using 3D physics for 2D things. So what 2D engineers did is they integrated native box 2D as the 2D physics bit. So you now have two elements of physics, 3D and 2D. Now, when I say that to people, they get very worried that they're going to make a 2D game and it's going to process the 3D physics on top of the 2D physics, so you have twice as much physics. I know I've said physics about 100 times happening in the background. Well, it doesn't do that. What it does is it instead only includes the physics you use. So if you make a completely 2D game using 2D physics, but you have no 3D physics in there, it won't include those in the builds. However, if you do make a part 3D, part 2D game, both using 3D and 2D physics, it will include both. So it kind of includes what you're using, if that makes sense. Kind of like if you use light mapping, you get rid of all the lights, it then doesn't use lights. So yeah, it's only including what you need. So with this physics, you can apply 3D colliders and things onto the 2D sprites. If you're doing like a thing like Minecraft, so you could put like a sphere around a pickup, and then when you come into collision with that sphere, then it's detected that you picked it up. But with the 2D physics, it made a bit more sense for them to basically add specific colliders for 2D things. So we have a circle collider, which is useful for balls and wheels, but in this case, completely useless for this shape. So yeah, we also have a box collider. So if I get rid of that circle collider, the box collider, which would be useful for platforms and planks, in this case, completely useless again. So what we have also is two. We have edge collider and polygon collider, and they both create colliders for your shape from two different ends, one from scratch and one from very high detail colliders. So if I do the polygon collider, what it will do is it will make a collider based on the alpha of the sprite. It's going to cut it all around. So I know what some of you are thinking, that's probably a bit too many sort of triangles for such a simple shape. And if you open up the collider info properties, you can see how many vertices it's actually using for this collider. So what you can do, and this is pretty cool, so you can hold shift. You can basically hold shift, leave Unity, it does it on the Mac version. Okay, there we go. Okay, I didn't have it in the right point. So if you hold shift, what you can do is basically... Okay, there we go. Right. I'm going to blame Parallels on that. It does it on the Mac, so yeah. So if you hold shift, what you can do is you can basically grab out the collider points and move them, and it will basically calculate how that collider looks. So what you can do is you can grab all these already points and then reposition them if you don't like them in that particular way. What you can also do is, as well as grabbing pre-made points, you can move your mouse in the line somewhere in between 2 points and then add another collider point and basically sculpt it how you want in holding shift. Okay, there we go. So then we can go click, click, and basically sculpt like a ramp or sculpt how we want our collider to be. So what we can also do is we can hold Command, or not. You can hold Alt, and we should go red. Okay, there we go. Okay, so if we do red, we can then delete points and basically trim it back. So if I say this hole is very overkill for what I want, I can basically hold that and go click, 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 get rid of all these points, and it will scale it back. And what you'll notice as well is the vertices count is now dropping. So if you prefer to then generate your whole collider and then scale back what you don't want and basically like trim the fat, you can do it that way. Now if you don't like that way and you want to work the other way, then you can remove that collider, and instead you can use the other one that's built in called the edge collider, which just gives you a bog standard straight line, and then you can basically hold shift and then basically sculpt your collider from scratch if you want to work that way. So it's kind of like, it's not like a silver bullet in terms of collider generation. It kind of gives you two different ways that you can work. You can either build it from scratch, it's more optimized, or generate a massive one and then kind of like peel back the layers. It depends how much clicking you really want to do. Yeah. The only thing is that a 3D collider and a 2D collider won't mix because it's two different physics systems. But 3D, you could put 3D collider on a 2D sprite and then that would collide with 3D objects. You could put a 2D collider on a 3D sprite and that would collide with 2D objects. I know that doesn't make any sense, but yeah, so you can do that sort of thing. There's a whole animation system, but I'm over by 5 minutes, so I will show you very quickly. So very, very quickly, because this is awesome, I really like it. So we have a thing called a Sprite Editor. So say like we have a atlas, which basically has multiple sprites in this atlas. What you can do is you can bring in a character like Iron Man, and you can set Iron Man to be a sprite, and instead of being a single sprite, it can be multiple sprites, and apply that. So then what you can do with this is you can then basically draw out cuts that you want to make of that atlas, and basically draw out these areas and cut them up. So if I then say to this Iron Man, I've already cut them all up into individual parts, and I click apply, what that's going to do in the project is going to take that one texture. Yep, that's pop up. So when I clicked apply and basically apply all these things, what you'll notice now is that it's taken that one texture of Iron Man, and if you see in the bottom right hand corner, it's basically sliced that all up into individual sprites for me to use. So you could basically get all your game's assets, put them into this one big texture, and then cut it all up and then put it into your game. So I could bring the Iron Man in and build him up, and I've got a working thing of him walking around, firing missiles and flying around, all animated in Unity as a little character. And as well as a shape like Iron Man, where things are put into that, you can also use a sprite sheet. Sprite, single, multiple. Let's get my Sprite Editor up. So what we could also do is basically, instead of cutting it like individual pieces, you can use the slice option at the top. You can say either cut it automatically. In this case, it basically goes around and cuts out around the edges, around outside all of the sprites. So if I have a 700 limbs character, the developer's not going to be up all night carving out individual slices. You can just go automatic, blip, or you can set it to grid, specify how big each frame is, and then slice it up into a grid, and then you've got individual slices for that grid. So then now in the bottom right corner, we'll have our character jumping, running, and punching, and things like that. So yeah, basically you can then take all those sprites and use the animation and animator to mix them up. But I'm way over, so yeah. Hopefully that's a nice little insight into the 2D stuff. There's a whole load of other things like 2D hinge joints and things like that, so you can have like swinging wrecking balls. I've got tons of videos of demos and things that I can just send. I'll send to Yuka and then just send to everyone, yeah, which demonstrate it actually in games that have used the 2D system and things like that. So yeah, that's cool. I think I've talked quite enough. Awesome. Maybe. Cool. Awesome. So. I'm sorry that I overshot, by the way.